Now, again sanity check for V out by V in as A tends to infinity, we see that A f tends to infinity. Therefore, if A f is a very large number by large number plus 1 is basically 1. So, there is no real problem, right. That makes sense, because we know that if A tends to infinity, V out is 1 over f times V in. Now, some jargon. So, this is called the forward amplifier. Right. This is the feedback block. Okay. And this is called the error signal or the error voltage, whatever. And so, this whole contraption is called a negative feedback loop. Again, as I said, that there is feedback is apparent, because some of the output is being fed back to the input, and why it is negative we will come back. So, if you stare at these equations, I mean one term seems to be coming up again and again and again in the equations. So, what is the most common term that you see in the equations? AF, right. So, this AF is basically is something that will keep showing up in all our calculations involving negative feedback, and there is of course, if something happens so often, right, it is better to give it a name. And this AF, how do we interpret this product AF? Staring at the diagram of the negative feedback loop, how can we interpret this AF as? I mean, what physical meaning can we attach to this quantity A times F? It could just simply be some number A, some number, I will take the amount of money in his purse and money in your purse and multiply the two numbers together, right. That is no real meaning, correct. So, is AF something like that, or can we attach a physical meaning to this number AF? Can you be a little more, I mean, so what physical significance can we attach to this number A times F? Pardon? No, that is all correct. If we call it something, as AF becomes large, the the error becomes 0, all that stuff. So, no, all I was trying to get at is that if I let us say I set the input to 0, all right, and let us say I break the loop at any point. So, I choose to break the loop there, correct. If I apply a small signal delta V there, what comes back here? What is the quantity here? Pardon? F times delta V. So, what is the signal at the input of the amplifier A? Minus F times delta V. And what is the signal at the output of the forward amplifier? Minus AF times delta V, right. So, now tell me what physical, how can we interpret this number AF? Yeah, okay, I mean, there is no input, you break the loop, you apply a signal at one end of the loop and see what comes back at the other end, right, because it is a loop, right. So, when you break it, something must come back from the other side. What comes back? The gain of what comes back is is A times f, but there is also a sign inversion, right. So, this is this AF number is called the loop gain, all right, and I mean quite literally it is the gain of the loop, right, and this negative indicates that you have negative feedback. So, in other words, if there is a disturbance here, the loop will act in a way to push that disturbance down, correct. So, basically this so this is so this indicates negative feedback and this is the loop gain. All right. So, now let us summarize our discussion so far. The gain A, all right. So, V out is 1 over f times AF by 1 plus AF times V in. This is what is called the closed loop gain. All right, is the gain from input to output when the loop is closed, that is what it means, right. And AF, this quantity AF is called the loop gain. All right, and so in terms of our newly acquired jargon, right, how do we write this? So, as the loop gain tends to infinity, the closed loop gain is only dependent on which block? Closed loop gain only depends on the properties of the feedback block. In other words, if the loop gain is very large, it does not matter how large it is, correct, all right. So, it is like saying, if I have insane amounts of money, it does not matter how much money I have, correct, okay, you understand. So, so whether the loop gain is, so for example, let us say the loop gain which is equal to or defined as AF is 10 power 4. What comment can you make about V out by V in? Is 1 over f times 10 power 4 by 10 power 4 plus 1, which is 1 over say some 0.9999 times 1 over f is what the output will be, what the gain will be. Now, let us say the loop gain became 10 times smaller, right. So, which is 10% of what it was earlier, that is a huge change, right. So, normally if something changes by a factor of 10, you would think that is a it's a serious problem, correct. I mean, just imagine if I went to your bank account and deleted off 1 0 in your bank account, right. That is a huge problem, but it would not be a huge problem if you are Bill Gates, isn't it? because there are so many zeros, right? Okay, you would delete one zero, it doesn't matter, right? There's that famous, comedy scene in Three Idiots. You remember that, right? That principal calls these three fellows and then put some large number with lot of zeros and says, miss this thing, and then finally it comes to Raju Rastogi and says, Rastogi, there's only 4 zeros at the end, and then it's a serious problem, right? So basically, if you don't have loop gain, it's like not having any money. So basically you remove off one zero and then it's a huge problem. But if the loop gain is very, very large, right? So the loop gain here has gone from 10 power 4 to 10 power 3, which would normally, you'd be very nervous about something like this. But let's go and calculate V out by V in. V out by V in is 1 over f times 10 power 3 by 10 power 3 plus 1, which is actually 0.999 times 1 over f, right. So, even though the loop gain is changed by a factor of 10, the closed loop gain is only changed in the some 4th decimal place, right, which is actually a very, very small change, right. So, therefore, the bottom line is that as the loop gain tends to infinity, the closed loop gain becomes only depends, its sensitivity to how sensitive the closed loop gain is to the loop gain itself starts to becomes very small, right. And as the loop gain tends to infinity, the closed loop gain only depends on the feedback block, right. And as loop gain tends to infinity, the error goes to error tends to 0. All right. And how do I how do you figure out? So, basically the next aspect that I'd like to kind of quickly point out is how to figure out if you have a negative feedback loop. So, to motivate this, I will give you 4 pictures. You can tell me which of them has got negative feedback, which does not, right. And let us assume that A and F are all positive in these examples. A and F are both positive. Which of these has got Okay. So, all of these are suspiciously similar looking, right. So, which of these loops are negative feedback loops, and so let me call this A, B, C, D. Which of the diagrams below incorporate negative feedback? Okay, so let's one person says A. Okay, somebody says C. Anything else? Only A and C. How did you get? How did we get? So that's indeed correct. So basically, A and C. That's basically this and this both incorporate negative feedback. But how do we get that? Yeah, break the loop. So the recipe is very simple. Remember that life does not come in block diagrams. I mean, you will hardly see in your lives. And only in the textbook you will see some picture like this nicely. There is one forward block and one feedback block and negative sign and inversion and summing amplifier. None of that stuff will show up in practice, right. It is all implicit in the loop. So, given an arbitrary loop, we should be in a position to figure out whether this is negative feedback in this loop or not. So, how do we figure this out, right? Okay. So, we break the loop. The recipe is very simple. You break the loop, you yank one side of the loop up, I do that in blue, and see what comes back on the other side. So, you break this loop. So, if this goes up, f is positive. So, what comment can you make at the output of f? Goes up or goes down? Goes up. What happens here? Goes down because there is an inversion at the summing point. So, basically that goes down. If that goes down, what comment can you make at the output of A? A is positive, remember. So, if the input goes down, the output also goes down and goes down by a large amount because A is very large. So, what do we notice? We broke the loop, we applied a stimulus on one side. What came back was in the opposite direction of was large. That basically is telling us that there is a large loop gain and it goes in the opposite direction. So, that is why there is negative feedback. So, this is the opposite direction of the stimulus, and therefore, this is negative feedback. All right. Now, let us do that for this guy here. So, if I yank this up, what comment can you make about the output at f? Goes down. All right. So, what happens with the input of the error amplifier? Goes up. If that goes up, the output goes down. Okay. And so, this is also the opposite direction of the stimulus. So, therefore, this is also negative feedback. Now, let us try this with say this guy. If I yank this up, what happens to the output of the feedback block? Goes down. If that goes down, what happens to the input of the forward amplifier? Goes up. If that goes up, what comment can you make at the output of the forward amplifier? Goes up. Okay. So, this is so what now? This is in the output is in the same direction of the stimulus. So, basically this is not negative feedback, right, and likewise you can break the loop here. Let us do that exercise. I yank, put there. What happens to the output of the feedback block? Up. What happens at the output of the input of the forward amplifier? Goes down. So, what happens at the output of the forward amplifier? Goes up. Correct. And therefore, again this is the same direction as the stimulus. Okay. And therefore, this is also an instance of positive feedback. All right. Okay. Now, if I exercise again, if I did the same thing, all right. Okay. Now, which of these is this is negative feedback and which of them are positive feedback? Oh no, A and F are both positive again. Yeah. So, basically it is straightforward to see that this is not negative feedback because you break the loop at the output of the amplifier, apply a stimulus, what comes back is in the same direction. Likewise, this, right. What about here? The opposite direction. What about this? Opposite direction, right. So, a common misconception that a lot of people have is the moment they see a negative sign here, they think it is negative feedback, right. It is that is not correct, because inversion can be anywhere in the loop, it need not be right there, right. So, for example, in here it is the inversion is in the forward amplifier. The only foolproof way of figuring out whether you have negative feedback or not is break the loop, apply a stimulus on one side, see what comes back on the other side, and if what comes back is in the opposite direction of what you put in, there is DC negative feedback. Does it make sense? All right. And so, I mean, for example, if you want, I mean, to give you another analogy, the legal system in any country is basically a feedback loop, right. It's like the forward amplifier in a negative feedback system. Their job is basically, the police stations are sensing the error between the desired state of society and the actual state of society, right. The desired state of society is that everybody is happy and nobody is complaining, right. But the actual state of society is like, people are getting robbed, people are getting killed, all that stuff. So, there are complaints in the station, right. So, the stronger the police force is, or the stronger the legal system in a country is, what do you think will happen to the number of complaints at the police stations? I mean, if God forbid, but if it's somebody says, well, if you throw a paper on the street, there's the death penalty, then all of a sudden, like there'll be no paper on the street, right? Or maybe that's because they killed everybody because everybody is throwing paper all over the place, right? But okay, you understand. So the strength of the legal system is basically it's like loop gain, right? If you have a very strong legal system, in other words, if the loop gain is very large, the error, right, which is the difference between actual behavior and desired behavior is small, right? So I mean, so if basically you throw tons of trash in the corridor, for instance, in plain sight, everybody knows that you're doing it, and nobody says anything. That basically means that there's no feedback. Right. So, you can basically do whatever you want and you get away with it. Now, if you if you throw a lot of trash in plain sight and people know that you have done it and they come after you with a tractor and say we are going to run you down, right, then that is negative feedback, right. So, basically there is going to be punishment for anything bad that you do. Now, you throw a lot of trash in the corridor basically and then they give you an award and a lot of money for doing a good thing, then you know that this is of course a small action has got a lot of reward, except it's in the wrong direction. Okay, all right. So, that is basically positive feedback. You understand? So, so again a very common conception is people see a negative sign somewhere in the picture and say it's negative feedback. Definitely the only way to figure this out is to actually break the loop and go around the loop and then figure out to see if when you excite one side, if what comes back is in the opposite direction of what you put in, then it basically means that you have a negative feedback. Does that make sense?